KIMO, I'll tell you why I asked the question, right? It was one of the loaded questions, because I asked the rumpus, the rumpus, the you know,
Yeah.
the most intelligent ball earther. He's actually he is the best at the debating. Apart from Jeremy. Jeremy's good, but different styles. But he says that it's not affected by gravity. So now we have a bit of controversy amongst the ball earthers.
There's no
So,
ball earther, as you say. I don't really know what a ball
shall
earther
The
we
is.
say-
rumpus said it is not affected, and Dr. Bob
shall we
says
say?
it is
Shall we
affected.
say? Shall we say two top ball earthers
Mm-hmm.
of the highest? Almost, aren't they? They're nearly right at the highest echelons of the ball earth debunker society kind of thing.
So, Dr. Bob, do you still think the gyro is affected by gravity?
Gyroscope is affected by gravity, yes.
Oh, he said it again, Ali. He said it again.
Yeah,
And
but
the
he
reason
didn't
it's
sound so
affected by
confident.
gravity,
Hey,
and the
KIMO,
reason it is affected.
listen back, and he didn't sound as confident as he did the first time, though.
He's trying to explain it, though, right?
Well, let's just double,
Gyroscopes
triple
are
check.
always affected by gravity, yep.
So you're saying, because I did say, Bob, it's not affected, and obviously you just thought you were going against me, but now you've had a chance to think about it.
I didn't really pay any attention to you.
Is the gyro, Bob, affected by gravity?
Yes.
But he said it again, Ali.
All right. How is it affected by gravity? How does it manifest?
Hang on a second.
Yeah.
I'll be ready.
Nice question. Good question.
He's right. I asked him that. He's run away. Ran away.
The only way I can think of is that it's going to put loads on the bearings and stuff like that. So that would be an effect. But its primary function is not based on gravity.
Not affected by gravity in any way.
It's not. Yeah, but if you're saying primary, but all mass, look, it doesn't matter. All mass, according to their thing, KIMO, their indoctrination or their protocols or whatever you want to call it, is that mass attracts mass. Everything that has mass, because the fact is gravity gives objects mass.
All right, I'm back now. If you want me to explain how gravity affects.
Oh, he's Googled it. He's Googled it. Okay, let's get some Google information.
No,
Bob.
actually, I got
no.
let him answer. From Sean Hodkins. I got that for my auto level. No, the reason that gravity affects gyroscopes is if you spin up a gyroscope, like a toy gyroscope, and let it spin on the table, notice that it starts precessing in a circle.
Yeah.
That's directly due to the effect of gravity, that precession. So yes, indeed, gyroscopes are affected by
that's
gravity.
friction, Bob. Bob, that's due to friction.
Moya, do you agree with this?
It's due to what?
That's due to friction. That's why.
Moya's confused
Yes,
now.
because it
Flexion?
slows down. Wait a minute.
No, it's due to gyroscopic
because the gyroscope.
precession.
Excuse me. It's not. It's friction, and because it slows down, that's why a gyroscope precesses, because it slows down, not because of fucking gravity. Yes,
no,
it does.
has to do with gyroscopic precession. Thanks.
Yeah. Okay. Yeah. Okay. Fair enough. You know what you're talking about.
You've confused them,
Yes, I do.
Ali. They don't know what to say now, what to think.
Well, they've got two different things to work with now. They've got two sides now. Gyroscopes get affected by gravity. Gyroscopes don't get affected by gravity.
Gyrocompasses are affected by gravity.
Gravity gives objects mass, because it's gravity that
Weight,
gives
not
objects
mass.
It doesn't cause. Yes, it does. It doesn't cause. It doesn't cause the acceleration. The mass causes the acceleration. So gravity gives objects mass. Mass causes the acceleration. Due, as KIMO's been trying to educate us on, the density in the surrounding area. So
Relative
dead
density.
easy. Yeah, it's dead. I don't. I'm kind of not full on with that.
Matters not. The point is, mass does not attract mass, which
it is kind of relative density, but it's a bit
right?
more intricate. It's a bit more intricate than just relative density, because of the fact that they have the little g in it and stuff like that, and or whatever they've got.
Well, Lemon's already admitted that gravity affects mass.
It's more subtle. No, in your world, Hey, when I talk like
Lemon's not in my world.
but wait a minute. When I talk like that, if I say blah 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 blah, right, is I don't necessarily buy into that shit that I'm talking. It's the only way I can communicate with you using words that you understand and concepts you understand. It doesn't mean just because I'm talking about it, I agree with it. You know, I'm like the United Nations. You know, the opinions expressed in this document are not necessarily the opinions of the United Nations. Well, that's the kind of given I start with. You know, even though I talk this, it's not necessarily my opinion, but I have to talk like that to communicate with ballers. Otherwise, you wouldn't understand what I was talking about. So,
Moyuk, what do you think of what Dr. Bob said?
I'm actually going through the physics of a gyro in my head and trying to square that with what he said.
Bob, can you help Moyuk understand how it affects, but it's affected by gravity? Oh, Bob talking gibberish. That's the problem, Dr. Bob. Rumpus has already told us it's not affected by gravity. And then you come along and say, no, Rumpus is wrong. It is affected by gravity. Now, Moyuk is like, well, Dr. Bob, can you explain to me how it is affected by gravity? And, still waiting. Genius.
all right. While we're waiting, KIMO, while we're waiting, what do you actually think about Ranty then? What's it? Because you. What do you think about it? Why do you think he's changed his one picture? Has kind of did that to him?
I'd rather not say. But you know, I mean, at the end of the day, it's his choice, his decision. Good luck.
Yeah. I'm the same. What you don't you haven't got an opinion on it at all whatsoever, or you'd rather not say.
I'd rather not say.
Oh.
But it'd just be interesting, like I say, to see how it develops.
What about right now? I asked you. I think you're the only one that's here, like me. What about the other guys in the panel? What do you think of Ranty suddenly changing over, and on one photograph after like 4 years of observations? Have you got any opinions on it or anything?
It's shocking, of course, but again, for me, it's I don't really have a strong opinion on it. Other than
no, I was actually asking. I wanted to know the other guys, the ballers.
Oh,
maybe
right, yeah.
Anybody that's got an opinion.
Yeah.
If anybody's got an opinion on it, is it good to have him, or you don't trust him, or what?
Quick opinion on the gyro. And
Oh, so all right, okay, go for it.
We're waiting for Bob, aren't we,
I mean,
to answer Moyuk?
yeah,
KIMO,
sure,
somebody-
but it doesn't. The gyro doesn't hover in air, so it is affected by gravity. It has weight, so.
Right, okay.
Yeah, I don't see gravity as being the primary function of what makes it happen, but it does affect it. It's, like I said, it's kept pinned to the ground because of gravity. It affects
Well, if that's
the
fun, it's just what you said
bearings,
there.
the loads on the bearings.
Can it work in space?
Gravity
Yes.
also affects the gyro by placing.
So
a
if it
torque
works
on
in
and
space,
that's the
is it
result
affected
of
by
its-
gravity?
Stop talking over me, KIMO.
Oh, now you
Don't
want to
talk
talk all
over
of
me.
a sudden.
Oh, let him talk,
over
KIMO.
me.
Let him talk.
Now, the gravity is what sets up the torque that sets the gyroscope processing when it's on your table. That's the gravity is responsible for the torque that's applied to the gyroscope itself.
All right.
What about in space?
You don't have it there.
So a gyro doesn't work on the ISS?
But I thought, wait a minute, I
No,
thought that
I
would be
said
inertia.
the gyro is not affected by gravity in space. That was your specific question. Now you're trying to change it to something else after I've answered.
No, keep it on Earth, KIMO. But that would be the inertia that causes the torque, right?
You wouldn't have inertia without gravity.
Wait, no, inertia. Wait a minute, inertia is resistance to movement.
That Marman
But
just
nothing-
said
We're not
inertia
describing
is
inertia,
gravity.
We're talking
It's
about the torque
gravity.
applied to the gyro.
According to you guys, gravity is an acceleration.
No,
Yeah?
no, no, no. Inertia is gravity, Marman just said.
No,
I didn't
no,
say that.
inertia
You know
isn't
it's wrong.
That's
gravity.
not what I said, Kimo.
Inertia is the resistance. Inertia's resistance to movement. That's all that
He
is.
said
Yes,
inertia.
Bob.
He said inertia uses gravity.
Bob, what I would change
I
is
said
in the statement you made. If I could set up a fictitious Earth right now, one that has no gravity, and I was to affix the gyroscope to the surface of it and spin it, it would still process.
So it's
I don't
not
think
affected by
would affect
gravity.
the torque. The surface of the Earth
I bet it would float away. I bet it would float away.
Yeah, but would
right?
it still work? Would it still
It's fine
function?
to my fictitious Earth. It's a
I bet
balloon.
it would float away. If
Yeah,
it didn't-
but Ali,
if
does it
didn't have
still
any gravity, it
function?
would just float away.
Does it still function though without gravity?
Yes, absolutely.
Well,
What
there
is
you go. So
Dr.
gravity's
Bob on
not a
about
function of
then?
a gyroscope. I don't know. I don't know. Sometimes.
Of course, it still functions without gravity. Why wouldn't it?
So it's not
Your
affected by
question,
gravity then?
again, let's bring you back to your question. Your question was, does gravity affect gyros? And the answer is yes.
But if it's
does.
still, so what effect? Does it slow it down, speed it up?
Kimo, it affects. It's not the cause. It's an
No,
effect.
what effect does it have? Does it slow it down or speed it up?
It
It
tilts it
holds it to the table.
and holds it to the table, but it also tilts it.
But that's not the function.
No.
So
Affecting it.
That's what
You
we're
You
talking
asked-
about. Does
you
it
asked
affect the
if gravity
gyroscope?
affected gyros? The answer is yes. Gravity does affect gyros.
What
It's not
effect does it have on
responsible
this
for the function.
on the spin of the gyro?
How many times have I already explained that?
You haven't
Before I
explained that. You
answer it
said it's
again,
on the
repeat back
table.
what I told you. Repeat back what I told you first.
You said it's on the table, but how does that affect the gyro spinning?
It does. What do you mean? How does it affect the gyro spin? What
That's
did I
what
tell
we're asking.
you?
Does gravity affect the gyro?
Yes, and
Not
I've
the
answered
spin,
that
the gyro.
repeatedly. What have I told you already? What did I say about precession? What did I say about the gyro being attached, being on the table? Being
it has no effect. Not listening, Dr. Bob. Mike's just explained to you
it has
no effect.
No,
I
he
don't
didn't.
think he said that.
Not what Moyak said, Kimo. Jesus, you're thick.
I said it's not the primary function. It's not what causes the gyro to do things. It's
Of
affecting.
course it isn't. It affects it, though. Of course, it's not the primary reason that it does what it does.
Kimo, does water affect a plant's growth rate?
So that's twice today, Ali. The globe earthers. Today they said the horizon is not geometrical, then it is geometrical.
Kimo,
And now the
Kimo.
gyro is affected by gravity and not affected by gravity. Double speaking globe
Brilliant,
earthers.
isn't it brilliant, Chemo? And that won't be the first time that you've been involved in a conversation like that, right?
Oh, problem with your
Within
thing is
10
You know what's
minutes,
utterly amazing is the
within
fact that you
10
take a
minutes,
true
Kimo.
statement and try and twist it to fit your narrative.
No, I asked you, and you said it never, and then you started saying gravity.
Who said never? Who said never?
Oh, you said it did. You said
Of
it
course
did,
it does.
right? And then you did not. Then you started saying gravity caused the precession of it, which was wrong.
No, that's correct. Gravity is the reason a gyro compass precesses on the table. When you spin it up and put it on the table, the reason it starts going in circles is gravity. Yes.
Why not? Why not electromagnetism?
You're welcome to try and measure it. Go
Well,
ahead
they've
and
done
conduct
that.
it.
They did
Buy the
that.
equipment and conduct
They
an
did that. Have you
experiment,
never seen
prove
them?
you wrong.
Didn't you see them? You must have missed that they went up when they were up in space. Great video of a guy putting a gyroscope as the so-called orbited the Earth, but as he got closer to the North Pole, aligned itself with the North Pole. So gyroscopes are affected by electromagnetic waves. like they are in an aeroplane. You should
No,
know that.
I don't think so.
What?
I don't think so.
Well, you go and do it. You done it when they were in.
All right, so you want to say that the gyroscope is affected by the North Pole in a spacecraft orbiting the spherical Earth.
I said
so
by
do you agree that it's in a spacecraft orbiting the spherical Earth and going over the North Pole? Does it happen at the South Pole as well?
Well, the South Pole is the actual, the attractive part.
Okay, so it does affect it over the South Pole.
Yes, it does, as it affects it over the North as well. Yeah, of course it does. When it reaches them
okay,
points
so
where
the Earth has a North and a South Pole. The Earth is a sphere. Welcome to reality.
So a gyroscope, I never said it was a sphere. As I
You
told
said
you
there's
before,
a South Pole and a
I
North
don't
Pole.
necessarily.
That makes it a sphere.
I gave a disclaimer earlier on. I don't anything that I say. I don't necessarily is my opinion.
Okay, so in other
Understand?
words, you're saying you're full of bullshit.
No. I'm saying I'm very
Okay.
careful. I have to
Is
learn
there
how
a
to
South
interact
Pole
with
on
you.
the Earth?
It's like this.
Is
It's
there
like this,
a
Paul.
South Pole
If
on
you
the
went
Earth?
to Russia,
Answer my question.
there is a point on the Earth that attracts a metal, and if you make a compass, it'll point in that direction. Yes. So there's something.
One or two of them.
There's some kind of force there. Of course there is. You can see it with a compass, or you could do it with a needle on a leaf in a bit of water. You could do the same.
Is there a South Pole on the Earth?
No.
Oh
Okay.
yeah, there is. Of course there is. Yep, I agree. Of
so
course
is
there's,
there
because
or
people
isn't
go
there?
there. People
KIMO
go there.
says no, and Ali says yes. So is there or isn't there? Do you guys even know if there's a South Pole on the Earth?
There's a place called the South Pole. Yeah, of course there
Oh
fucking
yes,
is.
yes. Yes, there.
That's a stupid question. Is there a South Pole? Of course there fucking
No,
is.
there isn't.
All
So it
contention.
seems so
There's a
stupid. You
place-
guys are in disagreement.
There's a place called the
No,
South
this is
Pole.
Not the first time flat earthers disagree with each other.
Chemo, there's a place called the South Pole, and people happen to go there.
Yes, there is. Yes, there is. That's correct.
Right, so there's a place called that, right?
Mhm.
Now, if you're saying if there's a magnetic South Pole, I'll also say yes to that as well, because there's a direction that a needle points, and that's called the magnetic South Pole. So yes, there is. Whether the same place or not is another fucking question, right?
Well, that's what the ballers do. Yes, there is. No, there isn't. No, there isn't. Yes, there is. Constantly, all day.
Only in your mind, Chemo, after it's been through the blender.
Paul
of
changed his mind
your
in less than
thoughts.
15 minutes. No, the geometric horizon, we don't have one. No, oh yes, there is.
All right, I've got a question.
I don't trust anything you say about a conversation I didn't hear.
All right, I've got another question then, right? It's about pendulums. Can we talk about pendulums? I've got a question about pendulums.
Yeah, go for it, Ali.
Right, okay. Oh, well, yeah, well, we can talk about it. Of course we can. Right, so say for example, I'm on one of the, you ever see the rockets, a guy gets strapped into a seat, you know, the safety test dummy thing, right? And I was
The
strapped
G-force,
into
the G-force
or
test.
you were, or something like that. Yeah, that forward, but with the rocket one. I mean, I can't remember what
On the
you called
train
it, the
track,
best
yeah?
one I could do. That's the baby, right? So, and I have a pendulum, right, and I swing it. Say for it, I swing it from left to right, perpendicular to the direction of motion that I'm going to go in. So it's at a 90-degree angle from the direction I'm going in, and I'm going to swing it left to right instead of forward, right? Right, so I started swinging, and then I shoot off along this fucking track, right? I shoot off along this track. Will the pendulum, if it's long enough, the track, and I keep accelerating, yeah, will that pendulum eventually swing forward and backward, and it'll stop precessing?
The moment that rocket starts accelerating, that pendulum is going to come and hit you in your face, and it's going to stay that way so long as you're accelerating.
Yeah, but I've got it far. It's not on a rope long enough to hit me in the face.
Then it's going to be towards your face so
right,
long
okay,
as you're
so that's
accelerating.
right, so it would. Right, fine. That's good enough. so it won't ever precess.
It won't exhibit movement like you're talking about. The force
Right,
would
okay,
be
so, right,
too
okay.
much to overcome. It would just be in your face. It would almost probably be motionless in your face, so long as you're accelerating.
Right, okay, all right. So let's go one further then. Right, say I'm on this track now, and it's in a big circle. Right, it's in a big circle now. I'm going round it again, the same way I was saying in yeah, well, it'll be a straight line basically, or whatever, right? A straight line basically, but it'll be in a circular motion, right? And I do the same thing. What will happen to the pendulum?
And you're turning left or right and
No,
accelerating.
I'm doing the same, right? Say I go with and it's accelerating. It's just getting faster and faster, right? It's not it'll get up to a certain speed, and I start it swinging, and then I head off in that direction. What will happen to the pendulum?
You said you started it swinging.
No,
It's
no,
already swinging?
it's swinging from left to right. I'm doing the same thing. It's perpendicular to my direction, which it'll be circular, but it'll be in a linear, you know, it'll be straight. It won't be, 45 degrees or something. It'll just be straight line. So what would happen to the pendulum then?
It'd be the same thing if you're talking about a straight line. Even if you're talking about a curved line over a surface, if you're going straight, then the force is going to be, you're going to have a force backwards because of the acceleration forwards.
Right. Excellent. But if I swing it from right to left or whatever, the minute I start taking off, and it'll keep that, it'll maintain that, and then say I reach a certain speed, yeah, in that direction. Will it then just go forward or backward, or will it go from side to side?
Yeah, it'll go forward and backward. Once you attain a constant speed and you're not accelerating or decelerating, then yes, it'll start rocking back and forth once you're at constant speed.
Excellent. Right. So what you've just done there is debunked the Foucault pendulum. Think about it.
No, because what you're talking about is accelerating. What I'm talking about
Nothing in that's
is constant speed.
You just said when you settle down to that constant speed, it'll always go back forward, because that is the way. Excuse me. Well, let me finish. That is the direction. You explained it. I couldn't have explained it perfectly myself. So now you have personally debunked the Foucault pendulum.
No, because you're mixing up acceleration. You're mixing up forces and acceleration and speed. No, because you made a big point, and I have to respond. Obviously.
Yeah, I know. That's what I'm saying. So now explain. Yep. The floor's yours.
You had to interrupt me to say explain while I'm trying to explain. Do you think that was necessary? And I'm going to continue now. You're mixing up forces with acceleration and constant speed. That's what you're doing. The Foucault pendulum isn't accelerating. That pendulum is not accelerating. The location's not accelerating. It has a constant speed depending on your latitude. So you're going to have that precession. You're going to have that back and forth movement. What you described was acceleration. If the Earth were rotating and accelerating, then yes, we'd experience something different. But that's not. You're making a false equivalency because you're mixing terms up.
Right. Can I respond to that then? Yeah.
Obviously.
Right. Okay. So if I get a ball and I put it on the end of a string and I swing it above my head at a constant speed, is that ball accelerating?
It'll have its own acceleration due to gravity. When it's at its highest point, it'll accelerate downwards until it gets to its lowest point, and it'll decelerate as it reaches its apex on the other side. But that has nothing to do if you start walking or running and accelerate. If you start accelerating, the entire system will have that force enacted upon it.
Right. If I keep that ball at a constant speed, forget about your gravity, right? Because I know that if I keep that ball at a constant speed, it won't be affected by gravity because of its velocity, as you guys say about the moon. That's why the moon doesn't crash into
No,
this.
that's not what we say.
Well, it is actually.
No, it isn't.
There's a difference between the ball.
I would say. You may have been talking to someone who was wildly mistaken, but that's not what anyone who knows what they're talking about would say.
Let's get back to what I was talking before we go off about the moon. We'll talk about the moon in a minute if you want to talk about the moon. But let's go back to that pendulum, right? Now, that pendulum, no matter which way you swing it, you are traveling in a certain direction. So if I swung, as you quite concisely agreed with, if I swung that from left to right and I was moving in a direction perpendicular to the swing of that pendulum, eventually that pendulum will straighten up and it won't precess again because there's a force being, what do you call it, put upon in that direction. So it's impossible. You're telling me that if I
hold on,
if I
you're
move,
making a lot of
if I
points, and you
move,
said something's
well,
impossible.
what you're saying, what you're saying.
We all let you finish your point. At some point, you have to make your point and relinquish the mic. So again, you're mixing up these forces with a constant speed, and it's simple. It's as simple as force is mass times acceleration. If you don't have an acceleration, you don't have a force. So if you're at a constant speed, there's no force being exerted on it. It's that simple.
There's a forward direct, which is a force. There's momentum. You're getting pushed forward in a direction. If you're going in a direction, there's a force that's moving you. Otherwise, if you don't put a force on an object, it won't move. So that's ridiculous what you're saying.
Momentum is not force; it's resistance.
So you're telling me, but wait a minute. So you're telling me if I stood on a roundabout, one of the kiddie roundabouts, or I'm standing on the earth, according to you guys, I'm not moving. Actually, I'm not really moving, even though I'm standing on an object that's moving. Actually, I'm not moving. That's what you're trying to tell me there.
I think the big problem that you're having, Ellie, here is
big problem. Nice bit of gaslighting there.
The
Nice
problem.
my problem.
Up, you
no, well, don't start with ad homs.
It doesn't matter. Let people finish. Address it when they're done.
That's not addressing the point. You're saying I've got a problem. Stop saying I've got a problem.
Rude person.
It's not a problem.
Yeah, you are a rude person. That's a problem.
He's got more than one.
Boo-hoo. Boo.
Okay.
Ali, these constant speeds aren't exerting a force. And the best analogy I can come up with is when you're in your car going 20 miles an hour at a constant speed and you're in a plane going 400 miles per hour, what different forces are you feeling? It's just a constant speed. There's no force being applied to you at a constant speed.
There's a constant acceleration or the constant speed right. If there wasn't a force, then I wouldn't be moving. Do you understand that?
What I'm saying is there's no force exerted on you when you're within this frame of reference, whether you're in a plane, in a car. It doesn't matter what speed. If it's a constant speed, no acceleration, but constant speed, there's no force being enacted upon you.
There has to be, otherwise I wouldn't be moving.
Okay, but again, that's why I have.
A seat, right, whoa. If I'm sat in a seat, it's the force of that seat, whatever. Right, we'll take it quickly, right? But if the seat's attached to a car, then it's the car that's putting the force onto the seat, which is putting the force onto me, which is bringing me along. Otherwise, I would get squashed because I wouldn't move. So there has to be a force because my body would be still. You can't move. If you're moving, you've got some force. There's a force there.
Not being enacted upon you. And that's why even in a plane, 400 miles an hour, why is it easy to stand and stay standing? Why don't drinks spill over if there's a force being enacted upon these things?
That's got nothing to do with it. That's got nothing to do with it.
A little bit, because you're talking about a force that doesn't exist.
A little bit, you said. I'm glad you said that. I was, yeah, go on then. I'll give you that then. Fair enough. You're being honest about it. At least you're not. Go on then. Continue.
But no, I mean that's really it. It's if you don't have an acceleration or deceleration, if your speed is not changing, you don't have a force being enacted on you. Now, if you're outside of the plane, we can talk about air resistance. We can talk about these different forms of drag. We can talk about those. But strictly talking about speed and acceleration, you're going to have a force with one. You're not going to have a force with the other.
Yeah, but if you go in in physics, if I've got a swinging a ball around my head, it's got a acceleration. It has an acceleration.
The ball will, as it's traveling, it's going up and down. It will have an acceleration and deceleration. The entire apparatus doesn't have an acceleration. It'll
No,
be
but
part of it, just the ball.
Even if I keep that at a constant, that because it's angular, it's classed as an acceleration. It's accelerating. The angular velocity of it is called an acceleration. It's accelerating.
What would be the angular velocity that we're talking about for a rotating Earth at a particular latitude? What would we expect?
You would expect, if at the equator travels at 1,000 miles an hour. If I was standing in the North Pole, it'd be 1,000 miles an hour. That'd be the angular velocity on the outside shell of them. There is no change because it's like, imagine, right? If a thing's traveling, how can you travel faster than the object that you're standing on is traveling at? So, like, if it doesn't matter if you're the equator, 47 degrees, 30 degrees, blah blah. But the centrifugal force will be more. It will be higher, but your speed won't. You'll still be rotating, but you'll be doing a smaller circle. So therefore, you would be, well, actually, you wouldn't be doing a smaller circle. You'd still be doing a great circle, no matter where you are standing. They'd just be smaller at an angle. No? Oh.
As we proceed to expose the globe lie, and they don't have any answers, Ali. The most intelligent person here is going to be of celebrity status, BIODUEL. He's the only baller that I've met.
KIMO, how come you can't be an adult and just have real conversations? Why do you open your note? Why do you open Microsoft Word and go to scripts?
I am having a real conversation. You're the only person I've ever met, spoke to, who've known to do real science on the globe side. This is that's
first. Very false, obviously.
Well, name one baller that's done science on your side.
I don't need to, KIMO.
I know
I'm an
don't.
adult. This isn't a dick measuring contest.
I know you don't need to because there's nobody that we can call upon that has done that. You are going to be the first, Bio. The first.
No, not at all. Not even close.
And so this man here, Ali, is a man I feel who's looking for the truth. He wants to know are the flat
We
earthers,
already know.
Are the flat earthers morons or are we the morons? What he's going to do is conduct an experiment to show the pulling force. Now I'm going to the week he does it, Ali.
What's the experiment?
Hold on, Ali. Hold on. I don't know if you know where. I don't know if you go on Dal's still, right? But Dal was he brought it to our attention. There's no pulling force. So when Bio shows this pulling force, yes, I'll be able to go straight into Dal's. Say, hey Dal, look, we've got Cavendish in a vacuum. All the variables have been accounted for. Everything's been isolated, and we know it's just.
Yeah, but what happens if it does? What happens if it does move? Is that your? That's it. It's a
That's
ball.
me done. Yeah. Flat Earth cooked. We've got science.
You actually think that? All right, okay, fair enough. I don't.
Why?
Well, what difference does it make? How they don't even look. If you looked into science, you don't have a clue what's going on. You're regarding that as say, oh yeah, because there's atoms and there's this force. You've got to accept that if that gets attracted, then you've got to accept the belief that it's atoms and all this kind of that kind of stuff. That I demand more proof than.
But why would they lie? Why would they lie? If they have science, I mean.
No, but I'm not saying they're lying. If they have the two balls come together in a vacuum, what does that prove? That two balls come together in a vacuum. Like I said, the Cavendish.
What it does.
Like I said with the Cavendish experiment, I've been saying for years. What does it prove? It proves nothing. It proves two lead balls or a lead ball gets attracted. So what?
Ali, look.
They won't be lead. It'll be different material.
No, Ali, but even if it is, right, wait a minute, listen. Look, if you go back and look at old papers, really, really old papers, do you know you can magnetize ivory? You can practically magnetize any substance on Earth, right? Quite easily.
I know, but what you're saying is that you're attributing something to something else just because there's a capability.
No, I'm not. No, I'm not. I'm saying, hey, by the way, there's this other possibility. I'm not. I told you already. What I say is not necessarily my beliefs. I can talk about magnetism and stuff like that. It doesn't necessarily mean I'm saying, oh, this is the reason.
You know that's not a get out of jail free card, right? You're still saying the words.
No, I know it's not,
you are thinking of the words and you're choosing to present them in your voice on your name. That's not a get out of jail free card as whatever I say I can't be held liable for.
Disclaimer.
You're going to be challenged.
Okay. All right, here. All right, okay. So, right, if no, well, that's going on to another subject about that disclaimer thing. So, basically, every time that I begin to talk, which I did already, I've already said in this hangout that what I talk about is not necessarily what I believe in. If I use words and you say, oh, he admits gravity, or no, I'm talking about the model, because I know your model and I know a little bit about the science, enough to know that they don't have a clue what they're talking about.
Ali,
I don't.
Let me say that what Bio was about to do, I'm not just doing this willy-nilly, okay? This has never been seen before by human eyes.
It has.
The fact that Cavendish in a vacuum has never been done should raise alarm bell.
It has.
Now, all Bio is going off is a paper that somebody did in a vacuum.
Multiple scientific papers explaining the methodology, explaining the measurements, and corroborating information with others, as well as being peer-reviewed.
Off of paper, Ali. So he's got tons of paper. I've seen it. Got tons of paper, and he's like, yeah, I can replicate what's on the paper.
Hundreds of evidences of corroborating material.
So you see how
with professionals.
That's why in the paper you write the methodology, so that people who read it can do exactly what you said, which is replicate it.
And see if you come to the same measurements, similar.
Steve, Ali, they're spiraling, because he's going to be the first person ever to see this with eyes. No one's ever seen this in a vacuum.
That's not true. I don't know why you keep saying
that. All right,
that.
okay, fine. Give Ali the observation.
I've said several of them.
Give Ali an observation of mass attracting mass in a vacuum.
That's not what you said at all.
Yeah, that's not what you said. You said no one has seen it. Now you're saying that Ali hasn't seen it, and we have to show him.
Ali, no one has seen it. They can't prove that anyone has seen it. That's what I'm talking about, Ali. This is
we can prove it because people make measurements, and part of taking measurements is using your eyeballs and looking at something. Human eyes have seen it.
See, Ali? That's all they've got, is that, oh yeah, somebody saw it. No one's ever... They've recorded Cavendish outside of the vacuum, but never inside the vacuum.
You just want them to do your work for you.
Right, well, I'll just butt in there.
What kind of scientist are you?
It's not that what do you call it? I don't believe that it's been done, or someone says that it's seen, but I would like to see it myself, to confirm it. That's what I like, and I don't mean about I need to see the ball go up into space and stuff. I mean that's a reasonable request. I'd like to see it. Yeah. I'd like to see that, because
Ali,
it kind of goes against my beliefs. Wait a minute.
You ain't gonna see it. You ain't gonna see it. You know why?
I am, because someone's just about to do it. BIODUEL's going to just do it. The experiment.
He's already famous. We already see Bio. You're gaining traction.
Talking about this. I don't care if stupid people know who I am.
You're good.
How about that?
Listen, you might need
an agent. Traction.
You might need a bodyguard. You might need you're going to be bombarded with people.
Nope. Not at all. As I told you before, flat earthers won't watch it, because then they won't be able to hand wave it, and globe earthers already know it's true, so they're not going to watch it.
BIODUEL. This is
BIODUEL. You're underestimating the power of the hand wave.
Yeah, I guess I could still watch it, but still hand wave. That'd be pretty powerful.
Me and you would probably have statues.
Anything that we say against it gets judged as a hand wave. That's a great rhetorical, tool. It's a hand wave dismissal. So anything that, just because we question it, it doesn't even if we're being intellectually honest, it's called a hand wave. That's such a cheap shot, Lewis.
A little bit. So with a classical Cavendish, with the what's wrong with the classical Cavendish? What's wrong with it?
Out of a vacuum.
Yeah, just a
Who you
regular
asking?
Cavendish like Blue Marble does. What is wrong with it?
Who are you asking, me or
You,
KIMO?
Ali.
You, because fuck KIMO. But yeah, I'm interested in what you think.
All right, okay. Describe it to me. What I watched the live. This is what makes me. I watched it. I found out his live. I knew he did a live stream, and I haven't listened to him for ages. But I went the other day, and have you guys watched it? Have you
Spit it
went
out.
to one of the live streams and watched it? Anybody?
No, not the entire thing because it takes for fucking ever.
No, I
But-
know, but I'm saying, have you looked at the setup? Or
Oh
whatever?
yeah.
And what did you think about it?
I don't know. What do you think about it? It seems like a very legitimate setup to me.
It looks like a good setup for the Cavendish, and it seems very precise.
How about you?
Well, it seemed to me there was a lot of electrical equipment in the area. Stars.
But don't worry, Ali. Brother,
Hold on, Chemo. Relax, Chemo. As far as the electrical equipment, you do realize that before the masses are introduced, that it comes to an equilibrium. Essentially, it'll not precess, right? It'll be essentially motionless. And then once it's motionless, then the external masses are put close to those small masses. Then we get that motion, and then it's come to an equilibrium after that, and that's the measurement taken. So
why do you have to take it so close? And all right, okay, I'll give you that. But as I say, but why do you have to put it so close?
Because gravity is the weakest force, and these are small masses, especially when you compare it to the Earth. So that's why you put it close to maximize the movement.
Just remember, Bio, you can't have the torsion
Chemo,
wire.
please stop interrupting. Please, this is actually a productive conversation. Please don't interrupt.
What about the gravity acting on the two balls then?
See, that's a legitimate question, yes. So that's why the torsion balance is set up in this way. So for our model, for our explanation, the way that we understand gravity is being pulled down by the Earth. So it's a downward direction. So this torsion balance is set up in which it'll move laterally. So it's not affected by this. It's perpendicular. So that force down isn't interfering with this lateral movement.
Now that's and how's that? How does that work then? If there's no lateral movement, it must be a fixed point, right?
Well, so it's hanging from a wire. So it's just a wire is hanging down and onto the middle of the torsion bar, and then at the ends of that torsion bar are a mass on each side, and then the only movement that you'll experience is laterally. Yeah.
Yeah, but you also what do you call it? Longitudinally as well, eh?
What?
It's like you're just making up words and saying them for no reason.
What's a longitude lattice, Lewis? Never mind. Anyway, let's get back to the bio, Joe.
So I don't understand what you mean by that specific term, but
right, the other axis. Well, a longitudinal. Yeah, if you said latitude, right?
Oh no, I didn't say latitude. I said laterally. So like sideways or horizontally.
But latitude is a derivative. Lateral is a derivative of latitude, which means
fucking nothing, you goddamn goldfish.
Well, it does.
That has nothing to do with what I'm talking about, though. The origin of words and the relationship between words, don't give a shit. So it's a perpendicular motion to gravity. So gravity from the Earth is not affecting it. What's affecting it is a mass next to it laterally.
But there's two forces acting on it, yeah.
There will technically, yes, but the gravity from the Earth is not. It's not affecting the motion. So it'll keep the wire taut. but it won't affect the lateral motion of the torsion bar.
Yeah, but I thought when you combined forces, it came to the so if there was a force pulling sideways, there was a force like when you strafe in the computer games. You know, when you strafe, you kind of go that diagonal kind of way because you're exerting forces of a side force, a forward force, so you go like in a diagonal. And I thought that's what you did.
Right. If we didn't have the wire, that would probably happen, but the wire prevents that. It's only going to, and then because it's balanced on either end, you're not going to have a tip of either. All you have is lateral motion. It's perpendicular to the mass of the earth and gravity, that force. It's perpendicular, so they're not going to interfere with each other. The only thing that they could do without that wire would be to compound with each other. But because you have that wire, you're preventing that compounding.
All right, okay. So now we'll get back. Now we'll get down to the lead. So if I, for example, so if I have a small ball that's being the attractive force that's in its what do you call it? It can't move, right? It's fixed, right? And then you've got the big ball on the torsion.
You have it backwards. The smaller mass will be balanced.
Yeah, I know, but
on
I'm
the
saying if you
bar.
did that, yeah, I know that.
Oh, yeah, if you did that, yeah, you would expect to have the same effect, yes.
So could you, like, for example, have a like a sensor on the small mass, the small kind of calibrated mass to feel the pull of it on the one on the torsion bar. So you could actually, so you've got the big ball on the torsion bar, and then you've got the little lead ball attached to like a spring device that measures the opposite of a scale. So
right,
you can
but
actually
that's what you're
feel
measuring with the
pull
wire,
of
though.
pull.
The wire torsion is, yeah.
Yeah. But if you done it, if you done it the opposite way, put the sensor on the, no, shall we say the fixed. Say for example, you knew that the big ball pulls on the small ball. Whatever. I don't know what you would measure that. How many kilograms pull per second or gravitational, whether it's the acceleration, the 9 point whatever force. So that little object would accelerate to the well, it wouldn't accelerate at 9.68 because it would have the opposing force up pulling it down. So that
It'd be a really, really small number. G is a very small number, but it is a constant.
No, but I'm saying the difference, right? So if you had how much gravitational force was pulling the big ball down, right? And how much gravitational force the other ball, the lead ball, was going to move sideways, the attractive thing, you could find out the difference, the actual, and then what you could find out that speed or that measurement or whatever, and then you could do that experiment I talked about. Hang it on the torsion balance, the big one, have the little one there, and have it set to the acceleration that you experienced. You know, that whatever movement or like.
Ali, I posted a
Yeah, he
Cavendish
said it. You
simulator
gotta
in
put
the
like
chat.
the bigger ball on one side, and you gotta put the smaller ball on the other side.
Perfect. So there's a Cavendish simulator in the chat. Blue said that it does represent what is going on, and he has another source in which they confirm that the simulator is accurate. So what you're exactly talking about, you can put in, you can swap the masses in this simulator, and then you can see what the effect would be.
Yeah, but isn't it better seen? Do you know what it's like? If you guys knew there was like 150 squillion different ball earth models and stuff like that, and with your GPS, it's okay to find your hang position, but if you were actually going to do any decent surveying, you would take you would use a different system, kind of thing. So these simulations are just simulations. They're just rounded off. That's why you know, when you see the wind traveling around the earth, around your globe, and all beautiful lines and stuff like that, that's not how it is. It's more random than that. That's just an idealized. Wait a minute. That's just an idealized version of it. It's not reality. It's replicating an idealized, according to the laws of physics that they've got. You know, you can't track wind. You can't put a mathematical equation to wind or the ripples on
You can do all that. I don't mean to interject, but it's been so goddamn long. I don't think that you at all addressed Blue's Cavendish experiment and what's wrong with it. I feel like you didn't address it at all, and we're slowly getting away from that.
He said electric, too much
all right,
electric.
okay, I'll address it. Let me address it, and then whoever was talking there can talk then, right? I'll address it. Is because two balls coming together doesn't prove to me that the Earth is a spinning ball and its mass attracts mass, or maybe all it proves to me is two lead balls. Two lead balls, when hung from a bit of wire and put on the end of a thing, attract each other. That's as far as I can go. Any further than that, guys, and do you know, if I'd said that, right, if I'd come up to you guys, right, you didn't know anything about this, right, you didn't know the shape of the earth, and say, hey, by the way, guys, look at this. I've just done this experiment. There it is. Do you know we're living on a spinning ball that's traveling at 1,000 miles, spinning at 1,000 miles an hour and 66,000 miles an hour around the sun and all that, right? You would think I was crazy. You would think I was crazy. And
no, you're extrapolating too far. All it is showing mass. It's doing is showing mass attracting mass.
No, excuse me. No, no, but it's not. That's what I'm saying. Yeah. So what is showing? That two lead balls attract each other, right? So what?
It's different materials that are being experimented with.
So the implications, Ali, right. Implications are when the question is asked, is there any scientific evidence for gravity? Is there any scientific evidence for gas pressure without a container? These lead balls, as you put it, will explain that.
Yeah, they already do.
No, they do not. There
right,
no
they already do.
Now.
Your personal ignorance doesn't change reality.
We'll show Ali then. Mass attracting mass in a vacuum.
It's not required to be done in a vacuum.
See, Ali, they can't do it. See, this is why it's important.
KIMO, it's very simple. Watch this. If you want to have because you're droning and saying the same goddamn shit. I can predict every goddamn word you're about to say. You know that.
Go on then.
You work off of a script.
Go on then. What am I going to say?
It's not required to be done in a vacuum because of two reasons. One of them being really retarded, and the other one being fine. First, QE's bullshit scientific method that you adhere to, the whole flat Earth community adheres to, means or once the experiment done within reality, our experience. Our experience is within an atmosphere, right? So the experiment should be done within air pressure.
You doing the talking, partner. But I've got to be able to say something. We are in this together.
No, you don't.
I wish you would say something from time to time, but you continue to say nothing.
Well, there's no going back. There's no turning back.
Yeah, there's no going back.
Okay. So you have to provide science, and I'm saying to Ali here why it's important. Very important, Ali, that we have science for the heliocentric model. At the moment, there is none, zero, nothing out there that we can call upon and say, this answers that. See, Ali?
Well, if that's your attitude now, there's that would right there. That statement alone tells me that once Bio does this, it's not going to change a fucking thing for you.
Yeah, it's going to answer these questions.
No, it's not.
How can I say, how does water stick to a ball again?
They already have food goals planned.
At the moment,
the question has already been answered, KIMO. That's
with
the
your
point.
poetry, yes. I asked you.
No, with the experiments that you've been shown.
What experiment?
He doesn't even know what we're doing.
So,
exactly. So you have Blue's Cavendish, about a number of other Cavendishes, especially I can't remember specifically who, but someone did it within a container, which prevented the displacement of air. as a cause.
Where's your Cavendish?
Blue did that as
Was
well.
air in that container?
Where's your modified version of Cavendish?
Mine?
Going to be air in the container, KIMO.
So
air.
mine's going to be in a chamber, and then under
no. It's
vacuous
going to
condition.
remove the pressure, Jeremy. That's what the cause is.
There's
pressure.
still going to be pressure. They can't get rid of it all.
What pressure?
There's going to be pressure in there
You
still
can't
after he
prove
makes
that,
his vacuum.
Jeremy, yes, there will be.
In a vacuum chamber?
What's being removed is over 99% of that air.
But Jeremy,
so if the air had anything to do with it, just by merely existing, removing 99% of it will cause a change in the effect.
KIMO, they won't do what I want to do. I want them to test all kinds of different stuff, and they're like, "Oh, you make it, you do it."
That's crazy that I have neodymium magnets to incorporate within the experiment. It's crazy that I have copper mesh to incorporate it within the experiment. And it's crazy that I have a list of a few other things to incorporate it within this experiment. So if you want to fight a straw man, fight it somewhere else.
You don't even know what you're doing.
I'm just saying, we got to do it a bunch of times. Like, do it with the copper mesh and in the vacuum, and then do it out of the vacuum without the copper mesh.
Exactly.
And do it out of the vacuum.
I didn't even think about that.
Like,
and you have to
just
spread
keep
the
switching it
Cavendish
up
out.
and seeing if you can, make something happen.
Yeah.
Is that what I do? I didn't even think about that at all. I was just gonna glue and tape everything together.
Why aren't you guys doing that?
Who's gonna pay for that?
Jeremy, this is going to be the best scientific experiment we've ever seen.
Jeremy, you gonna put some money up for that?
He's going to account for all variables, Ali. All variables, electricity, magnetism.
Can I say something? Can I say something? BioDuel, if you need any help, like maybe a few bucks or whatever.
Oh, no, it's all right. We're a team, me and Bio. We've got everything covered. Everything's sorted.
Not a team.
No, wait a minute. I never asked you.
They are working closely together.
I never asked you. KIMO. I didn't realize you were the same.
We're a team. Yeah.
KIMO. Right, okay.
KIMO and I are not a team, for disclaimer.
He would never have done this if it wasn't for me.
Then. Right, listen. Whoever's going to do it, listen, let me speak. Whoever's going to do it, I'm willing to chip in a bit of money, BioDuel. Just hit me up with a DM.
I appreciate that. A few people have offered. But I'm not looking for it at this time.
You can send all of the donations for the experiment to me. I'm his financial secretary.
I was actually thinking of sending it to Sean Hufford.
Thank you, Ali. That's very kind of you.
Oh, that was touchy. You didn't like that one.
We've got the chamber now. We've got the pump. We're just waiting for a few more bits and bobs, and we're ready to go.
I'll put it out. I'll put it out this much.
To Blue Marble Science and get his granite spheres so he can do Cavendish with granite. It's only $200. Go. You want to support somebody?
No, I don't want to support him. He calls me a retard and a fucking idiot and swears at me and gives me all sorts of shit. BioDuel has refrained from doing so. So much respect, man.
The honest boy is a little bit different, even though he doesn't let me talk often, but he's one of the first guys who actually is trying to do the right thing. Like, show that mass attracts mass in the right way. And
here, I'll put it this way, because Jeremy's here, and he likes to make suggestions for whatever reason. Once I do the things that I would like to do, if someone has a problem or another variable, I'd be glad to send all of my supplies at cost plus shipping to whoever would like to add variables and account for other variables. I would be glad to send it off, and then they can perform the experiment the way that they want to.
So,
don't send it to Arwen. Don't send it to Arwen. Whatever you do, don't fucking send it to Arwen.
If he pays for it, I don't give a shit who gets it, as long as it's paid for.
Don't you dare send it. No, even if
Arwen's getting it. Make sure Arwen gets it.
Don't you fucking dare, man.
I'll give it to Arwen for 10% off. Everyone else is charged full price.
How much you want to bet the guys didn't do all complaining won't take that up?
But Ali, this is a game changer. And how will anybody be able to ask the question again of how do you have gas pressure without a container?
Easily.
Don't ask me any questions. I'm out of them.
It's going to cause havoc in the flat earth community, Bio, if you're successful. But because I'm 100% confident and we know mass attracting mass is a made-up idea, It's not going to happen. So you're about to bring many ball earthers to the flat Earth side because you're not going to be able to conduct this science and show that mass attracts mass.
KIMO, if that doesn't happen, it's going to shake their world.
Absolutely.
No, it won't, because it'll be my mistake somewhere, or it's just too small. In which case, I would reach out to David because he has a 3/4 inch acrylic sheet, and I would just make the chamber bigger and then test it again.
So I'm expected to be a glober if it's successful, but if you fail, then you're going to be like, "Well, let me try. I made a mistake."
Right.
He'll keep trying until his.
That's the first true thing you've said in like 3 days.
He'll just keep trying it until you get it to happen, but he won't check for a bunch of different variables and shit. But
that's crazy that everything that you mentioned I've already accounted for and paid for, and it's at my house.
So you're going to do it with the.
Jeremy, what exactly test are you doing? What are you doing to get the flat Earth across to everyone? Besides
something going.
Besides just telling people that they don't know how to do stuff.
I have something going. The subsolar point thing.
Yeah, I've got my guy from India waiting to go.
I'm waiting on Bio for his Indian guy.
Are you talking to me?
Oh, if you're waiting on me, I'll pull the trigger. I just need to know when you're ready.
The first time, Sean, me and Bio are doing an experiment that's never been seen before.
Jeremy, that's the point where you tell Biodiesel that it's time and you want to do it now.
Stop saying we.
Yes, but like
we need.
Go on, Jeremy.
We need to know whenever his subsolar point is. That's the day he needs to be ready on.
Yeah, I'll look it up. I'll ask him and I'll get some type of latitude.
Thank you.
Ali, don't you think Dow will be impressed with the pulling force? Oh, he's gone. But I think Dow will be
This
very
isn't impressive.
impressed. I think Dow will be... what?
This isn't impressive.
No, because there's no such thing, Jeremy, as a pulling force, is there, at the moment?
Yeah, but they can get it to do it out of the vacuum. I don't know why it wouldn't work in the vacuum. I think I don't know.
Great point, Jeremy. Great point.
What's just going to work outside the vacuum? Look at all that pressure that is there to offer it a push.
That is a good point. There is a lot of pressure out there.
Except it's stationary and pressure, so oh well.
Right, Jeremy. The difference is whether pressure exists and when pressure deviates. That's when it can cause it. But if the air pressure around the Cavendish isn't deviating and it's a constant pressure, that's not going to cause motion. And if it does,
but think about how slow air pressure. Think about how slow air pressure deviates. You could have a point. You're only getting a very small, minute change, and the difference in air pressure you would get would be very tiny too. So just
Perfect.
Now that I've actually thought this through, who knows?
Perfect. Hold on 2 seconds. This is why before you introduce the mass, you allow it to get to equilibrium. Because let's say that it was true that air pressure, even a constant air pressure existing around it, causes motion, you would never be able to get to equilibrium before you introduce the external masses, right?
Right.
It would be in motion.
Hold on. Yeah, once you put the balls on, you now have more surface area for this pressure to react off of.
What does that even mean? What does that even mean, Jeremy?
We understand what it means. Just remove the air, and then you won't see it move. That's what we.
You don't put the balls on. I don't understand, Jeremy. What do you put the balls on? The balls are already on the torsion wire. Then there's the external masses.
Right. There's 2 sets of masses. Yeah.
It's a funny old experiment. Most people don't really know how it works.
Fine. We're talking to Jeremy right now.
Oh, no, most flat earthers don't
I see
know
what you're
how
saying.
it works.
The balls are on there. Everything's hanging and it's still.
Right. You allow it to not have motion, and that's why it takes so long, because half of the experiment is they're allowing the equilibrium before the masses. So once it comes to motionless, then everything is taken care of as far as accounting. Then you introduce the external masses.
Hold on. It probably takes so long because you get lucky and catch it at a moment where the pressure is relatively still, and then you add the masses and you've got to wait for an hour while the pressure changes.
So what made the pressure change? It's inside of a sealed box.
Air pressure is constantly changing all around.
It's inside of a sealed box and it is stationary.
Is the pressure not constantly changing, or is it static pressure?
Whatever's happening to the air pressure, that's always happening. And
is there a static pressure in the air?
Stationary. You tell me whether it's static.
Is there?
Boom.
Moving. It's a constant air pressure in one spot all the
time.
Container,
you tell me. And it's stationary.
In the vacuum. When I'm not talking about in the vacuum, I'm talking about whatever Blue's got going on.
There's no vacuum. There's air in there. And it's sitting still. It's not moving. It stopped moving. The air is not moving it. There's no motion of the ball.
So if you change the pressure, you're telling me you can't change the pressure in a sealed container won't change if the pressure outside changes?
That's correct.
There's only like 100 hours of video you can go watch.
Are you sure? Because
what kind of scientist are you?
Shitty
what about the potato chip bag on the dashboard going down the mountain? Doesn't that pressure change?
Is he going up and down a mountain with his garage?
Obviously
no, but the pressure is
the room, Jeremy. They're in the room.
Okay, your suggestion is that air pressure changes in the room every day, all day, in keeping with wherever you place those masses.
Hold on,
I don't.
The chip bag expands on the mountain because the air pressure outside is changing, Jeremy.
Yeah. In the bag doesn't change. You fucking genius.
Are you sure?
Go to hell, Jeremy. Now.
Stupid.
Well,
Yeah.
I mean, I wasn't even talking about that kind of pressure because you can't show a balloon lower than sea level and it's shrinking. So I was talking about the pressure from the walls of the container.
Yes, you can, KIMO. You can take a balloon to, say, Death Valley, which is 200 feet below sea level, and do a test there.
Yeah, so somebody show that. That's not my claim. That's your wild, outrageous claim. If you can show it to be true, then you're onto something. But right now, Blue has pressure inside the container.
You suggest because all you do is monologue bullshit.
Blue has air in the container, therefore pressure. Push. Pressure push. Of course it's going to move. Obvious. Every day. Take the air out, it's never going to move. Simple as that.
Yeah, but if it's pushing in all directions, then it's not going to move because the net force is
He's looking
zero.
for that right kiss. When it hits it in the right sweet spot. That's what you're waiting for. That's why it takes so long for a current to swirl around and kiss the ball.
So it kisses it just right.
Just right. That's what you're waiting for, Louis.
Every time. Every single time. The only time it ever kisses it just right.
Time? Show me every time. What do you mean every time? There's about four experiments. What do you mean every time?
No, it's been done way more than 4 times.
Where? You got Blue. You've got that one where
Blue's done it more than once.
A temperature change would change the pressure inside the box, inside the container.
Or keep it with the direction of travel towards the masses. The temperature changes that way. Huh?
Right.
Do you guys keep the temperature controlled in these?
Yes.
Bio, is your temperature going to be controlled? That's very important for pressure.
Jeremy, they're going to always move at the same rate, the same speed, in the direction of the masses because of the temperature change.
Right, like,
he's going to have a
the thing that
slight
seems to be
temperature
missing here
gradient.
is like,
Hold on.
Anytime you want.
Hold on. I'm wondering if he's going to have a slight temperature gradient from the bot. You know, how many temperature gauges you're going to have, Bio? KIMO, you got to make sure this is all.
Well, yeah, but why does it matter? Like, the whole point, you let it sit in equilibrium before you introduce the masses.
And then you're adding,
if there's anything
adding a bunch
else
of mass with different temperature, possibly. You got to make sure the temperature is controlled in this.
Yeah, you know what? Why don't we get Blue a hold of Blue and tell him that we want him to heat one side of this thing, and then you've got a unequal distribution of heat, which might, in your point of view, cause a tremendous amount of disequilibrium and pressure. And holy fuck, we can't have that. Well, if it's got it,
the force is very tiny,
and it doesn't do a fucking thing, then we know you're retarded.
Lewis, the force is very tiny.
Now we've got BIODUEL.
They're spiraling.
I wouldn't want to be around Blue when they say it.
We do have this wonderful thing also, Jeremy. Those balls are
you can't show mass attracting mass.
Jeremy, those balls are room temperature. So the massive heat and cooling from the room temperature balls being moved close to the box. Wow, that is just insane.
Boy, we can never believe your story.
In there.
Well, I mean, you are measuring a very small change in these balls, so who knows?
From the same temperature balls.
That's not your balls.
Look, Jeremy, Moya, forget Blue. We've got BIODUEL. Remember the name. He's going to do something that's never been done before.
We're not going to forget him. We were talking to Jeremy right now.
Well,
right.
I don't think talking about you.
I don't think we should forget.
Real scientists. We got real scientists on this.
We should not forget Blue, because you have made many criticisms of Blue's experiment based on faulty assumptions you're making about the nature of reality. Blue is in a perfect position to test your retarded assumptions.
Okay, how far away are the balls? All right, how long do you let the thing sit there for, the torsion bar? How long do you let it sit and make sure it's perfectly still before you add the other balls?
How many videos of the experiment?
5 minutes, 5 hours,
about 100 hours. You can go watch
100 hours, and how do they make sure it doesn't move by?
No, it does stuff. But if you want all these questions,
how do they make sure it didn't
go
move?
watch it? Go watch it.
They just look at it and they're like, "Oh, it's not moving now."
We've got BioDuel. What is wrong with everybody?
Uncut video, it's there.
But forget about Blue and all the others before. That wasn't done in the scientific method.
This is what we're talking about. Why is this a problem for you? Because you're a fucking retard?
Because anything before
bio, KIMO, you just spout bullshit over and over again. We've heard it. You don't have to say it again. So just sit back and actually start learning something.
So we've got BioDuel about to perform an experiment.
Okay, we're not talking about BioDuel.
So you guys got to do it on both sides. You got to have 2 balls
that amplifies the effect.
And then you add 2. You can't do it with just one mass because
one.
You could be. I think that's part of your problem.
Yes, you could. That would just make the effect half as much.
What do you mean one mass, Jeremy? You have 2. A little one and a big one, like the moon and the Earth, or the moon and the sun.
Actually, KIMO, there's 4 masses involved.
Well, you can do it like that, yeah.
I want to see the moon go on one side. I want to have the moon and sun on the east side of this thing, and then have the moon and the sun go onto the west side of this contraption and see the contraption move. But you guys say it won't happen.
Nah, dude, you didn't test any of the other directions. What's wrong with you?
Can we work through that for a second? Okay, the moon is on, let's say, the right side of the device, and the sun is on the left side of the device. They're pulling on all the masses in there. What direction of motion will that cause, the equal pull of the moon on all the masses?
No, that's what I'm saying. I want to see it on the right side. The moon and the sun on the right side, and then I want to get the moon and sun on the left side.
Yeah. No, I understand. What effect? Try and think about it. Let's open your mind up a little bit. I have a force on the right side of my device. It's going to be pulling equally on both of the small masses. And
no, that's why I said you got to do it with one mass. You got to do it with one mass.
It would cancel out, wouldn't it?
That's the test right there, KIMO.
It would cancel out, wouldn't it?
The moon, the Cavendish, sun, moon, Cavendish.
Answer the question, please.
Go on, Moya.
Answer the question, Jeremy.
I know it'll cancel out with two. When you have 2 masses in the torsion balance, yes, it'll cancel out. That's why I said you need to do it with one. That way, we don't have an equal effect on both the sides, and you could have the moon and sun be on one side, and then go to the other side, and be like, oh look, the moon and sun are pulling the ball.
Why would the moon and sun pull both? And how are you going to have a torsion balance with one weight?
I know you got to figure something else out.
No, you don't.
Yeah.
Yes, you do.
Jeremy, I think you should think about the lengths you're going to just to maintain some reasonable in your own mind.
I think you're mad.
Can't we do that with frictionless thing and just set it still?
What?
Why are we using torsion balances when we know about quantum locking? You're doing old shit. They're doing old shit on you, KIMO. They're trying to get over on you with this, KIMO. I'm fucking telling you.
You should probably learn what quantum locking really is.
How are you gonna use quantum locking if the entire point is that it's locked in place, Jeremy?
No, those things float around. They have tracks and shit, bro.
Yeah, we're smarter than that.
What's that quantum shit where they got the track and the thing floating around, no friction? You can make you could do that in a vacuum, and now you got a really frictionless environment.
Wow.
I'm just saying they're doing old shit on you, KIMO. They're using barbaric.
Quantum locking isn't frictionless.
You try and learn about what the real world is doing before you start going off.
That is interesting to think about, though. Would it be possible to do that with quantum locking?
Hell yeah, man! You guys are doing old shit. They're playing you on this, KIMO.
You have to keep it cold. There's going to be thermals and everything involved. I don't know how you do it.
No. That doesn't matter. You could just. Well, I guess you got to keep it cold. That's the thing. You got to keep the track cold.
So what? You get the thing cold and you add your mass. If it's just mass attracting mass,
it's because of that cold.
Hold on, Sean.
So if you're doing that, the Cavendish, therefore it won't work.
Well, I'm
pushing the ball.
Say it again.
Just for the purpose of entertaining you people, you could have a quantum. You could have a track that's being cooled like in a constant supply of liquid nitrogen. And then on top of that, you just have a very thin floor of a vacuum chamber. And then you could have your quantum locked masses inside the vacuum chamber.
One mass.
The thing that you chill is
the whole point of this is to use one mass so we can see the sun and the moon pull this thing over when it gets on the other side.
Right, and then you could also have the other large mass inside the vacuum chamber as well.
This is the experiment, KIMO.
The thing that you're moving, though, and I'm not sure if this can be reversed. I guess it could be, but the thing that's super cool is usually the thing that moves over the track. It's the puck. It's the what do they call it? Superconductor.
Yeah, the magnet. I mean, the superconductor. That's right. But yeah, it's cool. It's actually cooler for the perpetual motion thing Jeremy was trying to make before. It wouldn't be perpetual motion, but you'd get pretty a lot of.
Forget about that, Kosho. Forget about that. We got a new.
It would do nothing for the Cavendish experiment.
Stop trying to pull one over on.
We got a new experiment for the. It's called the sun moon and dish.
Jeremy,
and we're going to
superconductor is not going to help you do a Cavendish. It's just going to add to me. It's going to make it obviously move.
You can't set something still on a when it's locked quantum.
It's going to be. It's still going to be
in motion.
Whenever it loses its temperature slightly, it's going to move slightly. It's not going to stay perfectly still, and you're trying to.
You can't get something to sit still on there. Are you serious?
No, you can't.
That's fucking bullshit. You guys feel like you guys are lying.
Look up what you're talking about.
Yep,
I know what video you're talking about. You'll never see one that's just stationary. The reaction that it gets is what's moving it.
Oh no! You can get it to be stationary, but it's not good. The whole point of a Cavendish is you want it to be completely stationary, and there'd be no chance that something else is making it move. And when you have you can have it sit stationary, but it's not going to sit perfectly stationary. It's not going to be stationary for very long, even if you kept it cold.
Why?
Why?
Yeah.
Because even the slightest movement is going to be what you're looking for in the Cavendish experiment, and you're going to have a lot of noise because you have a frozen magnet in there.
Look at all the steam coming off, or the steam, or the gases coming off of that fucking frozen puck.
This is the first time, Jeremy, they're taking this seriously, science. They're all panicking. They don't even worry about it.
You notice, though, that Jeremy just changes topic in order to avoid answering the question of why he thinks air inside of a sealed container is fucking suddenly changing direction. Always coincidental with where the external masses are placed.
Because air moves in all directions, so it could.
And if it moved all directions, it wouldn't stabilize in one direction. You fucking
Who on earth has got it to stabilize?
So what?
Who has stabilized their torsion bar?
Once the mass is in place, the masses will remain off-center in keeping with where the masses are after it finishes its oscillation.
Yeah,
when he's watching the torsion. When he's watching the torsion bar, what method is he using to make sure it's stationary?
Yeah, he didn't.
Is he lining it up with something?
The same thing that measures it.
Hold on,
is he lining it up with something, or
the same thing that's going to measure the movement, Jeremy, is the same thing that can measure it not moving.
Look,
we can measure movement.
Are we really arguing whether or not pouring a liquid on the Cavendish will make it move?
No. How did you get the torsion bar to stay still?
You wait for it, you retard.
And how will
what kind of answer is that? You wait for it? What kind of answer is that?
It will never stay still.
It's the answer. You wait for it to stop moving.
It's too sensitive.
It's not too. It's not too sensitive. You're just fucking wrong.
Okay. That's not a very good answer.
Well,
it's not a very good answer.
I think on the scale 1 to 10, it's 11.
Show the torsion bar that's not moving.
Okay, the blues videos.
Exactly.
Show the timestamp.
You show me a torsion bar that's not moving, and I'll show you a guy that's
Alright,
tired.
show's over now. Veach and Kosh are here to ruin it and play
Did you
games.
just interrupt me? Did you just interrupt me?
guys.
Did you just interrupt me, Kimo? What is your problem?
We'll catch you next week or the next hour.
You're unreal, man.
You're